right, part 6 says first to find our x-intercept. Well, if we plug in 0 for y, we'll come out getting 1 equals 0, and that's not true, so there's no x-intercept. And then lastly, number 7 is to graph everything. So go ahead and get your calculator, and we're going to plug this in and graph it. So we plot the graph of the original equation before we simplified it and took out the x plus 1. So this is the graph that you have here, which you can see the x-intercept is at 1. If we look at the table here, we can notice at the value of -1, we have an error here simply because there is a hole at -1. So when I'm putting together my table, I'm going to just go with some values like, I'll start with -3, then -4, 2, 3, and then 4. So for these values, I have 0.25, 0.2, 1, 0.5, and 0.33. So I'm going to go ahead and just plot the value here of what my graph looked like. So going back to what my graph looks like, it's just a sketch. As long as you don't pass through that hole, you are good to go. So this is a graph of my rational function of x squared plus 1 over x squared minus 1. All right, let's look at the last example. So we have x squared minus 4x plus 5 over x minus 3. So looking at this, not really too much I can simplify that's going to cancel anything, so I'll leave it as it is. So my first step is to find my domain. My domain is simply going to be -infinity to -3, and then union 3 to infinity. Sorry, this should be a +3. So infinity to +3, union 3 to infinity. Number 2 is to verify if there are any holes. Well, if I simplify this, I'm not going to get any holes, so there's no holes. Step 3 is to go ahead and identify our vertical asymptotes. So I'm going to set the function, the denominator set equal to 0, and I get x equals +3, which tells me my vertical asymptote is at x equals 3. So I'm going to go ahead and plot that point. So 1, 2, 3, vertical asymptote. All right, number 4 tells us to identify our rules for our 3 cases that we have. And so if we look at this, we deal with the cases. It's not the case 1 where we deal with the degree of the denominator is higher. We don't deal with case 2 because both denominators are not, or powers are not equal to each other. We deal with case 3 where the degree of the denominator is smaller than the degree of the numerator. So we have or capital D over lowercase d. So if the degree of the denominator is 1 more than the degree of the numerator, in which we do have that exact notation here, that means that there is a slant asymptote for y equals mx plus b. So we have a slant asymptote for y equals mx plus b for our slant asymptote. So by looking at this, that means we take on doing some synthetic division here for our numerator. So this is the first time we've seen this. So we have our value for x equals 3. So if we set the denominator equal to 0, solve it, we get x equals 3. and we take the synthetic division by doing 1, -4, 5. And we do this by synthetic division. So we have 1, 3, -1, -3, and 2. So we don't care about the remainder. So our actual equation, remember that this is now x and this is our constant, and this will be classified as our remainder. We have y equals mx plus b, which is y equals x minus 1. Right, so we have our slant asymptote equation, which gives us y equals x minus 1. So we'll go ahead and plot this slant asymptote here. So we'll go -1. From here we'll go up 1. And kind of estimate the rest of it. But this is our slant asymptote. Probably should definitely make it dotted. There's no confusion. So slant asymptote has been formed. The next part, which is part 5. For part 5, we need to find our y-intercept. So again, we take 0 and plug it in for x. So we'll have y equals 0 squared minus 4 times 0 plus 5 over 0 minus 3. So that means that y equals -5 over 3. So our y-intercept is 0, -5 over 3. Then we have part 6, which is looking for some x-intercepts. Remember our x-intercepts, if we look at doing x squared plus 4x plus 5 equals 0, we have to either do the quadratic formula or we could do completing the square. Regardless, we'll end up with the imaginary numbers. So our x-intercept, we have none. Does not exist for it. So our last part, which is part 7, would be for us to graph it and form some type of a table. So go ahead and graph this, plot this. I'm going to have 2 tables this time. So I have 2, 1, and -1. Give me the values of -1, -1, and 2.5. And then my other part would be positive 4, 5, and 6. And that'll give me 5, 5, and about 5.6. So I'm going to go ahead and plug this into my calculator just so I can see the graph here. So we have x squared minus 4x plus 5 over x minus 3. Here is our graph. So I'm going to go ahead and plot that point for the y-intercept, which was -5 over 3. Intercept, -5 over 3. Maybe right. Here's my one graph, and the other one is up here. So this is an example of a slant asymptote for your horizontal asymptote and how you would begin to solve it. So don't forget to complete your homework for this and have a great day.